Participants, welcome you all to the first session, Introduction to Machine Learning Algorithms. I believe in this whole 6 days of this FDP, you are going to explore a lot of different areas specific to AI, focusing on deep learning, NLP, and all those generative AI concepts. So, in the first session, I would like to give an overview glimpse of ML algorithms. So, I will be going through different aspects in today's session. So I will talk about the roadmap for machine learning because as instructors, when we teach students, we should they should know the roadmap of machine learning because they have to understand. When we go and teach them, they should know why is this course important. If you're teaching this course machine learning, why is this important and how does it fits, and what all career opportunities we have if we study this course. So that overview I'm going to give. Then I'm going to talk about the fundamentals of machine learning, like the mathematics behind machine learning, and some basic terminologies which we'll be using frequently here and there. Then the most important one, the type of ML algorithms, different machine learning algorithms, and also in simple terms. So in simple examples, because when we teach to our students, we should there are a lot of ML algorithms and they are confused sometimes to remember them. So some kind of simple examples which can make the students and also to us, if you are learning ML for the first time, this will definitely help you in understanding machine learning algorithms in simple terms. Then also some miscellaneous activities such as model evaluation and validation, what all things we do in this. And I will be ending my topic with the limitations of machine learning and why we go for deep learning algorithms. So the first one, roadmap. This is a common roadmap for somebody who wants to become or who wants to study machine learning or to become a machine learning engineer, right? The first and the foremost important step here is the mathematics. And if you see in the next slides, I will be talking about little math behind the machine learning. So when you talk about this mathematics, whatever mathematical foundations is required for machine learning is not new. There is no new concept. It's all existing, what we have been studying in our schooling or maybe in plus one, plus two, or in our UGPG degrees. So all the probability, statistics, and linear regression, calculus, all those concepts you have to be perfect. This is the first important step. That's why before you start learning machine learning, you should revise the mathematical concepts. So this is one foundation point. And because again there are a lot of definitions, some people say machine learning is mathematics. That is nothing new there. So this is one. Then you have to know the basics of programming languages. So we very frequently use these two programming languages, Python and R programming, for implementing the ML algorithms. People talk about Python, but still R programming has a lot of demand for implementing the ML algorithms. Then the student or the learner who wants to become a machine learning engineer should focus on the database part. So because in traditional databases in academics, students generally study about Oracle. They study the course DBMS, and we talk about Oracle and the SQL programming language for writing queries. However, machine learning, the heart of machine learning is data. Without data, we cannot perform anything in this machine learning or in the whole AI system. So this traditional DBMS or this SQL language might or might not fit for machine learning data sets. So we have to study some special kind of databases like MongoDB, which is a NoSQL database, because the data is not always in the form of a table. You cannot have the data as columns and rows. So there is a necessity that the data should be the data can be in any format. It can be image, it can be a text, it can be an XML format, it can be a JSON file. So that's why it is important to focus on the database as well. And thereon comes our these three makes the foundation for learning machine learning. So before you actually start learning, the prerequisite, or we assume that you are aware of these three, then we can study about machine learning and all those stuff related to machine learning. So please, when you teach or when you learn machine learning or when you want to teach machine learning, please focus and stress more on mathematics for machine learning. Rest all proceeds with the course, but this is one aspect which I want to highlight here. What are the different career opportunities we have with machine learning? These kind of information will motivate the students to focus on this course of machine learning, or maybe generative AI or AI in general, whatever you call. So this is again, this we will talk about this in later slides, because this talks about the ML flow. But to understand different roles, you see, data engineer and data scientist, they work in the starting few phases of the ML workflow, and ML engineer and the ML developer focuses on the second half of the ML workflow. So different roles like data engineer, data scientist, ML engineer, data analyst, and ML developer, research scientist. These are the different career opportunities which are open and available in India for our students. So let's understand each of them in detail. These are the different opportunities, or you could say different roles, what student can achieve by learning this course of machine learning. Let us see the differences and the importance of these four different ML rules what we have. So to become an ML researcher, again, ultimately, if you see this one here, if the student or if the person or the candidate associate is focusing on the data part, then he will become a data engineer and a data scientist or a data analyst. So this part of that, no, the first half of the ML workflow, it focuses more on the data part. So somebody focuses on data. Again, we use the term as data science here. So we use the concepts of data science. So if the student focuses on these concepts, then there is scope of picking any of these roles. And if he is talking more about model training, model evaluation, model building, validation, then it is likely that they might land in an ML engineer or ML developer role. So let's see what are the focuses of each of these roles. ML researcher, what he has to do, ML engineer, data scientist, data analyst, what they do. If you see here, let us focus from the this side, data analyst. So analyzing and interpreting the data, and data scientist, he extract insights and build the models. Whereas ML engineer, implementing and optimizing ML algorithms. Researcher, deploying, designing and deploying AI models. So it is following the strategy of that ML workflow here. So each, like in each step we keep doing it, they have different, but what are the skill set required? So if you see here, SQL, data visualization and statistical analysis for, again, same thing for data scientist or data analyst. Whereas for ML, it is important they know about the different ML algorithms and some advanced concepts in ML or in AI, like deep learning, NLP and computer vision. So in this workshop or in this FDP, we are focusing more on these two part, or maybe these two components of the AI, that is of ML, and also the deep learning, NLP, and the computer vision, its applications, and what all tools they have to study. If you see again the ML part, they have to focus more on the packages, libraries related to Python programming, whereas data scientists and data analysts, they have to focus on a lot of tools like Excel, R, BI, and other libraries available in the Python. So this is the just an overview of different roles and what is required to become a particular thing. Earlier, before I go to the next slide, I will like to talk about the branches of their engineering degree. People who used to learn CSC, it's a traditional or it's a myth that they can become software engineers, or somebody is studying mechanical engineering, he can become a mechanical engineer. So in that case, talk about this AI. When you talk about this AI, it is not the power of computer science. It is not the what I mean to say. They do not. It does not belong to this computer science. AI is a very generic subject. It can be included in any curriculum of any particular engineering branch. Why? Because it has mathematics, which is a common subject for all branches, and it has programming. Again, it is a common subject for all branches in the beginning, and then it has all the ML algorithms. So it is not a particular copyright or belonging to only to computer science or allied branches. AI is a very generic and common course, and everybody can aim for such jobs in now. Again, different terms. I know when people talk about AI, we talk about today again in after generative AI, we are talking about LLMs, large language models. So, what is this term AI? Where does this ML fits? What is neural network, deep learning? This is how the pipeline looks like. But explore and understand these terms with examples. I will take one simple example to explain you all these terms, how and where they fit inside each other. And also along with that, something called as LLMs, the large language models, based on which today's advanced AI models such as ChatGPT or DeepSeek made upon. Again, this is a small a picture which is talking about the different skills based on a Russian doll. So if you see the on the doll, what all stuff computer science has, what all stuff data science has. So machine learning is just a part of AI. It is a sub module of AI, though it is same. That's what you see, almost both the dolls are same, only the size is different. So it is a sub part of this big one, AI. So computer science, all this means all the data science, AI, machine learning are part of this computer science. It means they are already available in computer science courses. Nothing is new what we are learning here. Let's try to explore the meaning of AI, ML, neural network, deep learning, all with a simple example. I will not talk about AI, I'll come back to this. Let's talk about machine learning. This is just to give an awareness to you how each of these terms are different. Somebody says deep learning, somebody is talking about machine learning. What is generative AI? What is neural network? How and where they fit? To take an example of teaching a robot how to bake cookies. So there is a robot, and we want to teach that robot to make some biscuits, kind of how to make it. So in this example, teaching a robot is the task. So when this is the task, what does ML does in this? What deep learning can do? What neural network can do? Let's see. So machine learning is about teaching by examples. It is all about teaching by examples. It means when you want to teach a robot how to bake cookies, you have to show him the examples of good and bad cookies. So ML focuses on teaching the robot. Okay, so see here what I'm trying to do. Instead of giving step-by-step instructions, we don't tell how to do it. We will show some examples of good and bad cookies. Okay, so this is the task. Again, you will get a proper idea when we see all the different terminologies. So this ML, it is teaching by examples. We will show the robot some good and bad cookies, like something like this. I will show some 100 cookies. Some of them are good and some of them are burnt. So it can understand, it can learn from that. So the key idea in machine learning is ML uses data to train the robot to make predictions or decisions. Now, if you see the next one, that is neural networks. Same task. Task is same. How to teach a robot? We have to teach a robot how to bake cookies. So, what is neural networks here? In ML, I told it is teaching by examples. You are telling that robot, you are showing some good and bad cookies and telling that you learn from this and make the cookies. That's what we are doing there. Whereas in neural networks, the robot's brain for learning. What we do here, we actually no tell that robot, we give an idea for that robot to learn the relationship between the inputs and the outputs. Previously, we were only showing the product. See the cookie, this kind of cookies are called good, these kind of cookies are bad. Learn it and cook it. We are not telling how to cook it. But here in neural networks, what we are trying to do, we are telling it to understand the logic, how you are trying to make the cookies. Like we will tell what are the inputs, we will tell what are the outputs. So the robot's brain will learn the relationships between the inputs and the outputs. For example, in neural networks, what we do, so this is again for the task of completing teaching a robot how to bake cookies. The neural networks, what we do, it will we will give the input, that is baking time, temperature, sugar level, and output good or bad cookies. But there are some hidden layers. That's what that is what we are finding the relationships, right? So some relationship like too much sugar burn cookies. So the in when you talk about neural networks, they focus on how is that cookie made. The robot will learn, understand the relationship, how much time it has to bake, how much temperature it has to put, and how much sugar level it has to add. So it's like that's what it works like, biological brain connecting neurons to find the patterns. So compared to machine learning algorithms, neural networks is little advanced. We are telling it to study more in detail about the relationship between the inputs and the outputs. So here the idea is to are the computational framework behind ML models. So same as how we learn. When you learn to solve a problem, or when you learn to solve some when you learn to cook something, you will understand the how much water to add, how much coffee powder to add, how much sugar to add. So all those complete details we discuss in neural networks, not in machine learning. Let's move to the next term, that is deep learning. Okay, neural networks is fine, we are able to understand. But what about deep learning? If the same problem is given, teaching a robot how to bake cookies, how this deep learning plays a role? Let's see that. See, layered thinking of complex baking. Here, what we do, instead of again, I would say in neural networks we are finding the relationship between the inputs and outputs. In deep learning, we use lot of neural networks. One for focusing on the sugar level, another one focusing on the baking time, another one focusing on the temperature. So we do lot of things. A lot of neural networks are used in deep learning. But one more added feature in deep learning is that we learn from the images. So in deep learning, it uses multiple layers of neural networks. See, it uses multiple layers of neural networks. So neural networks is simple. Deep learning, it is combination of multiple neural networks, like recognizing shapes or textures of cookies from images. So this is important point here. Images, we in deep learning we play more with the images. So the data what you're going to play with contains images, you have to use deep learning, right? So the idea here is to intricate features and relationships such as visual details in the cookies. So when we talk about data set as images, we have to think about deep learning. Then generative AI. What is this generative? People are talking about this generative AI. How is this linked with the same problem? Teaching a robot how to bake cookies. See, machine learning, it was seeing only the cookies, good and bad cookies, and it was learning the knowledge by seeing which are good and which are bad. It is deciding to make that. That's what we are talking at a very high level. Neural networks, it was also thinking about the relationship between input and the outputs. Deep learning, it learns from the images. By seeing the images of the cookies, it is identifying what is the length of the cookie, what is the edge, how much thick it should be, what all no toppings I should add on the cookie. By seeing the images, it is learning those three. Now, when I talk about generative AI, the robot creates new recipes. Okay, I am teaching a robot how to bake cookies. It is learning. It goes beyond learning. It is not only learning, it is generating. That's why generative AI, it is generating new ideas. So if I teach a robot to make cookies, what it will do, it will invent new recipes, something like this: double chocolate with a hint of cinnamon. It is generating new recipes. So from the existing thing, generative AI can help us in generating new content. So generative AI produces original content based on the learned patterns. And the last one, large language models. What is this? LLMs. Here, the robot learns to chat with cookies. Chat about cookies, sorry. Meaning, robot is making the cookie. You can ask robot some questions, it will answer. So that is the picture of this LLMs, right? So if you see, LLMs are specialized models trained on massive text datasets, right? So you can ask the robot. how do I make chip cookies? It will tell you the answer. So large language model LLMs is on the topest level where it is telling us how to make it. It is, see, the goal was I should teach the robot, but using LLM, robot is teaching. Robot is telling me how to make cookies. Okay, so that is the power of this large language models. So now if I go back to the term AI, we have seen all these things how it is doing. So AI is an umbrella term for all these concepts: ML, neural network, deep learning, generative AI, LLMs, everything fall under the umbrella term AI, right? So the basic idea, teaching the robot to act like a human, right? So you will give the instructions, it will do. So like ML, like deep learning, AI is the umbrella term, it will do everything, right? AI is about mimicking intelligent human behavior, right? So what all intelligence we have, how we do in life, what all policies and principles we apply and follow to solve our own life problems, same way the machine should be able to do. That's what the goal of AI is. So this is just to explain you about these important terms which always are trending when we talk about AI. People talk about deep learning, generative AI, neural networks. So what all are these? They are all linked to each other. We have seen with an example how the problem of teaching a robot about cooking the baking the cookies, right? How they are linked to each other. So this is just to explain you about the relation between those different terms. So everything is different and they have their own style. Like, because if you want to teach the robot by showing the actual cookies, I can go for ML. If you want to show some images, I can go for deep learning. If I want to ask the robot to give new ideas, I have to go for generative AI. If I want to chat with the robo, or I want to ask some questions and it should answer help me, then I have to go for large language models. So that idea I wanted to give it here. The next part is machine learning and the mathematics. As I told you, the important step to start learning machine learning is mathematics. So what is the relation between machine learning and mathematics? If you see here, mathematics is the heart of machine learning. This is one definition from one of the textbooks. The other definition is machine learning is mathematics. So I strongly believe machine learning is not new. Programming is already there. Mathematics is already there. It is just a name given to create some hype or to create a separate naming given to the existing concepts grouped together. All that mathematics, all that programming grouped together, we are calling it as mathematics. Okay, so that's what. Machine learning theory is a field which intersects the statistical, probabilistic, computer science, and algorithmic aspects. So it is combination of some mathematical concepts, computer science, and algorithms, right? So mathematics is the very very important foundations. So this is from one textbook, mathematics for machine learning. So generally the four pillars and the foundations of machine learning. Regression is one important. Anyhow, we are going to learn about these things. Dimensionality reduction, density estimation, and classification are four important pillars for machine learning. But the most important point is the foundations. So what all mathematics do we need for machine learning? Vector calculus, linear algebra, probability and distributions, analytical geometry, optimization, matrix decompositions. These are few important mathematical foundations. Before you start going to machine learning, you should learn all these things. Why linear algebra? If I talk about linear algebra, just an example, if I talk, see, linear algebra is there since our school. We are talking about matrices, we talk about rank of a matrix, we talk about eigenvalue, eigenvectors, we talk about different types of solutions for a matrix, we talk about vectors, right? We talk about the properties of vectors. All these comes under linear algebra. Now, how is this linked with machine learning, right? So when you talk about the important approach or one application of machine learning, that is prediction. When you want to make some prediction, you have to build some ML model. So to build an ML model, we need data. We need data set. And if the data set is in the form of an CSV file, it can be considered as a matrix. It can be considered as a matrix. So what all operations we do on matrix, the same thing we'll be doing on the data set here, right? So I will be talking more when we go for the regression task about this matrices part there, but this is just to tell you that foundations of mathematics are very important. You should know all these concepts. For example, matrix decomposition. We have one algorithm called dimensionality reduction, or that is one technique what we have in machine learning, dimensionality reduction. So it means when I have a higher dimension data which is of multiple columns, I would say in simple terms, when I have such huge data with me, I cannot visualize it. I want to visualize the data and see how the data is distributed. So in that case, if I, for example, if I have a 3D data, okay, I can visualize by turning the sudden, by rotating it to some directions, x-axis, y-axis, and z-axis. But what if I have data of higher dimension, like 4-dimension data? I cannot visualize it. So I have to break down. I have to remove some unwanted data from that. I have to reduce that. To reduce that data, we might go for matrix decomposition, or sometimes when the data set is very high. So suppose I have a matrix of 6 cross 6. Data set is of 6 cross 6 size. It is very easy for me to calculate the rank, to calculate its eigenvalue, to calculate the determinant. It's okay. But what if I have a matrix, or when I say matrix, I mean to say the data set. What if I have a matrix of higher dimension, maybe some 1000 cross 1000, or some 100 cross 100 you take. So when we have such huge data, a big data set, I cannot apply my mathematical techniques on that huge data. Then what we do, we apply some mathematical concept called matrix decomposition, where we decompose that matrix, the data set in the matrix form into small matrices. On those small matrices, I can do it easily, or my system can do it easily in lesser time without losing the original properties. Like this, each one of these concepts are very important and required for machine learning. So if you are a teacher, if you are going to start this course machine learning, you have to make sure that there is a prerequisite course of mathematics for machine learning. And if you are going to learn machine learning, make sure that you are going to learn all these concepts, and then only you are going to start learning machine learning. So this is about the mathematics part. So now let's any queries till now. Let me know if you have any queries, any doubts if you have till now. Any queries, you can ping in the chat box. I can reply to your queries. uh, am I the only one doesn't able? Can you see my screen, other participants? Is my audible, my
Sir,
voice audible? Right, now I have shared the,
yes, sir.
yeah, so in chat box somebody has given, maybe you can check from your side. Fine, no problem. So now let's go for machine learning. Okay, so what is this term machine learning, and how is it different from traditional learning? Why the word learning has been given to this, and how the naming convention has come, right? So a lot of definitions are there. Let's go through each of them and let's try to understand. See, one definition of this, it is a subfield of computer science that gives the computer a ability to learn without being explicitly programmed. See this example. Traditional programming, when you write some programs, we give the input, we give the code, and it gives us the output. We are giving the input and the code. Like C programming or C++, when we teach, we ask the students to write program to calculate the maybe some palindrome number, Armstrong number. We are giving the input, and also we are writing the code. Computer is giving me the output. That is traditional way of programming. Whereas in machine learning, we give the input, we give the output, we ask the computer to give the code in simple terms, to give the code. So the machine gives the relation between A, B, and C in machine learning. So this is one difference to show you the traditional approach and the machine learning approach. We give the input and we give the output. Now the computer will give me, now the machine will give me the relation between the input and output. That is the program. So in traditional, what we say, we say the output is equal to function of the input. So we give the input and the function, it generates the output. Whereas here it is a relation between the input to output. Okay, so the function is a relation from input to the output. So how these are linked with each other, that we get as the output in the machine learning. And little terms, common terms which we'll be talking about machine learning. Let's see the another definition of machine learning. It's a science and art of programming computers so they can learn from the data. So we are telling the machine, see our data, that is the input and the output, and learn the find out the relationship. Okay, so ML is about designing algorithms that automatically extract valuable information from the data. It's all about designing such kind of algorithms who will understand the data or read the data, understand the patterns in the data automatically. So there are three important core concepts of machine learning. One is the data, the model, and the learning. So because frequently we'll be talking about ML model, data set, and learning. The model is learning, the model is training. We use those words. So what is this data? Data is core of ML. Without data set, we cannot do anything. So the goal of ML is to design general purpose methodologies to extract valuable patterns from the data. So given a data set of, maybe one example could be, I will give you the students data of last 5 years post COVID, 2021, 22, 23, 24 pass out students data. And I'll ask you, which is that one common skill all those placed students had, which got them placement. So we have to analyze that data, see their resumes, go through their resumes. That is one textual data what I have. So that documents what I have, you have to go through that data, identify and extract the patterns. Okay, so that data is core, and then we call something called model. A model is set to learn from the data if its performance on a given task improves. When you are playing a game on mobile or somewhere, you will not know the rules all at a time, you will improve slowly. So that's what learning here. So learning can be understood as a way to automatically find patterns and structure in the data model and the learning. So the traditional approach, what is the traditional approach we follow in general? Study the problem. When a problem is given to you, how do you solve that problem using the traditional approach? Study the problem, write rules, that is writing programming, then execute that program and see whether that problem is being solved or not. If it is okay, if you are satisfied, you launch it. If you are not satisfied, you are try to analyze the errors in that and again go and start the process. This is what we generally do in traditional approach of solving any given problem. But the machine learning approach of solving a problem is little different. You understand the problem, you train the ML algorithm by considering some good data. By taking good data, you will train the ML algorithm, then you will evaluate the solution. If it is okay, you will launch it. Otherwise, you will analyze the error and study the problem. So if you see here, I'm directly writing a program for the problem to solve it. But here I'm having two components. I am playing with the data first. I am trying to understand data nicely, and then I am going to train the ML algorithm. This ML again, it's a program. This part, if you ask me, it's also a program like you have done in the previous approach, traditional approach, writing a program. But before I write the program, I am doing lot of data pre-processing here. I'm playing with the data. I'm trying to understand the data. Accordingly, I am choosing my algorithm. Then I'm going to train the ML algorithm. So this is the traditional approach. Even this can help us learn. Machine learning can help us learn. It is learning from the data. This is one very, very important slide. We are giving data to the machine, asking it to understand the data and learn it, and it will teach us also what it has learned. That's what the beauty of this machine learning or AI in general. That's what we are able to know. When I have the students' data with me, I'm telling the model, Please understand this data, identify the one important course which all my students in my college had that landed them in a placement, some job. So it is learning the data, and that input it is giving to me, right? So that's the flow here. Again, study the problem, train the ML algorithm, you get a solution, you understand the solution, you are evaluating it, you are seeing whether it has given nicely the output or not. Then you with that output you are understanding the problem much better. Again you are repeating the process. So the important point is, we are inspecting the solution as humans. What model, what the machine is giving, we are trying to understand that, we are trying to see the output. Maybe it is finding out, predicting what will be the number of jobs next year. I want to do some prediction. How many jobs will my college students get in the next year? This year placement was 80%, last year it was 70. Will it be 90 next year? That's the prediction I want to do. After the prediction is done by the machine, you have to analyze the output. You have to see the solution. Can we do it? Whether that whatever the machine has given, is it true? Is it fitting nicely? That understanding you have to do. That's where we are learning from the machine. General scenario of machine learning, how does any ML algorithms works, right? So the first part is the training data. We'll come to that aspect, training data, then train the ML algorithm, then model that, implement that ML algorithm, do the prediction, and if you're satisfied, if you're not satisfied, you go there. If satisfied, you are done, right? So this general flow what we do in machine learning. But for what type of problems can I apply machine learning? When I have to choose, see, in if you are from computer science background, we talk about some called dynamic programming, we talk about branch and bound, we talk about greedy approach of solving problems. So there are different techniques of solving any given problem. Here in general, for what type of problems do I have to go for machine learning, right? So problems which existing solutions require lot of hand tuning or long list of rules. Okay, so there are solutions for some problems, but it takes lot of program is very lengthy, it takes lot of time to solve it, and sometimes maybe I have to do it with my hand to get that output. For those kind of problems you can go for machine learning, because machine learning algorithm can simplify code and perform better. Means code will become code, the size of the code is very less, it becomes less, the it performs better, means it gives a response in quick time. That is one kind of problem. So any problem which has lot of steps to do, very lengthy programs are there, you can apply machine learning approach. One. Second, complex problems where there is no good solution in all traditional approach. In all traditional ways of solving that problem, if there is no good solution, you can go for machine learning, especially for complex problems. And the third one, fluctuating environments. If the environment where I'm trying to find the solution, it is fluctuating, it is changing, then also you can go for machine learning. And when we talk about complex problems and large amounts of data, when the input data is very huge for your program, for your that problem, then also you can go for machine learning, right? So these are different problems or different areas where we can apply the ML algorithms. So one important slide here, general machine learning project life cycle. So the first one is define the project, then define, you talk about the data, then you model that particular ML and you deploy it. This is a generic machine learning project life cycle. So today we are going to focus on that modeling part. That to select and train the model, we use some ML algorithms here. So we are going to talk about those algorithms, right? So this is all data science part, and this is all the ML ops part. So ML ops is one very good area which has more scope for research, and also for a job perspective. Somebody is planning, this is very less explored area, because you see lakhs and lakhs of paper people publishing only on the models, taking some data set, applying some model, and proving that their work is better than the previous one, something which is making that job easy. But still, till that, after paper publication or after designing that model, nobody is deploying it. So nobody is talking about how to deploy ML model. How do you make a outcome? How do you make a product out of that ML model, which you have proposed as a paper or as some assignment? You might have solved in lab some exercise of machine learning, but how do you productionize it? How do you convert it into a product? See, the best example, age calculator. You know about this age calculator, right? If you in Google, if you just type age calculator, it will ask you two things: give the date of birth and give today's date. And if you click calculate, it will tell you date, the age, and in years, months, and minutes, seconds, everything it will show you. It's an application. Underlying there is a small program which is calculating it and showing you the output. It is a product. That program has been converted to a product. In the same way, when people are working on a lot of ML projects, they are not converting into products. So why? Because it's this is an unexplored area. How do you deploy the applications in production, right? So that is one area which you can focus on, but our focus is on the modeling part of the machine learning. And some myth about AI, or what people see about AI, they think it's all data, and you give it to AI, it will give the value. It is like it's a program. You give the data, it will give the output. It's not actually. Actually, it contains lot of things. See, you have to do lot of data selection, data sourcing, synthesis. Then you have to do lot of data engineering. In that, you have to do cleaning, normalizing, feature scaling, right? Then in modeling, you do model selecting, training, evaluation, tuning, and then we deploy it. We do a lot of things, right? So AI is not about just giving data to it and getting the output. It has lot of steps involved. Like I've said here, it has lot of steps involved in each phase, right? So these are some what we say, basics of the machine learning, fundamentals of AI, or I could say the fundamentals required for machine learning. So if I just summarize what we have seen about different career opportunities and what skills uh, should be have to become to get those jobs related to machine learning. Then we have talked about mathematics, the foundations, and we have talked about what all mathematical stuff is required to learn and understand machine learning algorithms, or in general AI much better. Then also we talked about the definitions of machine learning. What is machine learning, and what is it, how is it different from the traditional way of solving any problem, and the machine learning way of solving the problems. Now let's go in detail about ML algorithms, different types of machine learning algorithms. What are the different types of algorithms we have? I hope no queries here. If no queries, we can proceed. Any queries till now? In general, any doubts regarding career opportunities or the mathematics skills? If not, I will proceed to the ML algorithms. Okay, fine. Yeah, thank you. Let's move to different types of ML algorithms. We understood now that machine learning is all about training. You are trying to take the data, you are trying to give the input and the output to the machine. Machine is writing, try to learn from the data. It is trying to learn from the data and give us the output. But there are different types of problem. Sometimes I want to know what will be the house price in New Delhi. If I want to purchase a house in New Delhi in 2026, what could be the price? Should I purchase in Mumbai or in Delhi, where it is cheaper? That kind of analysis I want to make. I want to know the price. That is one problem. Or there could be some problem where I want to classify whether it will rain in the month of March here in Tamil Nadu or not. I want to do such kind of analysis. So depending on the context of the problem, I will not say there are types of ML algorithms. I will say there are types of problems. For each type of problem, we have different algorithms, right? So it depends on the type of problem we are going to solve. So ML algorithms are restricted to two types of problems. Okay, so I'll just come back to that. If you see, okay, So there are generally ML algorithms are applicable for two kinds of problem. One is regression problem, the second one is classification. Regression and classification. So let's try to based on this there are categories. That's what I'm saying, if the problem is to find out whether it will rain or not, this is yes or no question. Other question was whether what will be the house price next year in New Delhi or in Mumbai. I want to know what is the price, what will be the price. What I'm doing prediction there. In both I'm doing prediction only, but in one I'm trying to get the value x. Here I'm telling yes or no only. I'm telling yes or no only. So if you want to find out a value, like what in the rain example, how much centimeters of rain will fall this year in Tamil Nadu, I want to find out that. Then you have that kind of problem we call as regression. And if the problem is about whether rain will fall or not, that is the second type of problem. So based on these two major type of problems, ML algorithms are going to help us. So based on that we are having different types. Let's see what are those different types. So there are different types of ML algorithms. One, based on whether they are trained with human supervision or not. So again, I will keep repeating the definition of machine learning. Machine learning, I will give the input, I will give the output and ask the machine to identify the patterns and answer my queries. My query, tell what is the house price today or gold price today. What will be the gold price next week? That is my question. It has to answer to me. So when I'm giving the input and the output to that, when I'm giving the data set to that, am I also helping it to learn? As a human, are we helping the machine to learn? Are we getting involved in that process? Then we call it as supervised. If you are not involved, it is called unsupervised. And then some other semi-supervised and reinforcement learning are different types of ML algorithms. Though there exist different types like online and batch learning, instance and model-based learning, we limit our discussion to very popularly used ML algorithms, that is supervised, unsupervised, and reinforcement learning. What are these three ML algorithms? Supervised. So you see here, regression, classification, two types of problems which I was talking about, they fall under supervised learning. Unsupervised, we have clustering and dimension. We will see. I will explain you all these terms. Don't worry. If you are new learner, we are going to understand what is regression, what is classification, everything in detail, right? Then we have something called reinforcement learning. So this is just to show you that there are three categories of ML algorithms. First one is supervised. What is this supervised learning algorithm? Here, the training data, what we feed to the algorithm, it includes the desired solution called labels. See this example here. Spam classification. Email. My training data set contains an email with a tag. It has a tag that this is a not a spam valid mail. This is a valid mail. This is a spam mail. This is a spam mail. This is a valid one. This is a spam one. So in the training data, what I am feeding to the computer, I am telling it along with the data, I am telling it which is good one and which is bad one. So there is some sticker. When you go to supermarket, you see some sticker on fruits. Apple, if you see, there is a sticker. And if you see anything you take, there is a sticker. There is a label which is telling me that what is the price of this, what is the how many grams is this particular food item, 500 gram, 1 kg. Everything is sticked on that. So labels are like stickers on the products. That's why your job is easy. No, when you go to supermarket, you take a product, you see that sticker. After seeing sticker, okay, you understood. No, this is the price of this is this much, and it is of this many grams. You're able to get that idea. So supervised learning is kind of helping us, making our job much easier because we are having stickers. So when you are telling that machine to learn from the data set, you are also having some labels to those mails. This is a simple example of email spam classification, right? So classification is one such important supervised algorithm where we will tell the along with the sticker. After giving this training, we will give a new instance without telling the sticker. Without giving the sticker, we will ask is whether it is a good one or a bad one. Okay, so that's about That's what, no, you learn through experience. You go to supermarket 10 times, 20 times, you are going every time, you know that 500 kg dal what you are taking. By holding that packet, you can easily understand this is 500 kg. How you know that? Because previously you carried some 500 grams dal packets with a label. That's why today you became experienced, and when I give a normal packet without any sticker on that, you are telling this is this dal and this is 500 grams, because of your experience. Same is your supervised learning. So you give the input, give the annotations, then you learn that, and it will make the prediction. When you give a new entity, it will tell immediately. By seeing that, it will tell yes, it is grapes. So another one is regression, right? So in this case, in this supervised, it is just mostly, this classification is mostly for yes or no questions. Sometimes yes or no, sometimes 1 and 2, sometimes 0 and 1, but limited fixed outputs. Whereas regression, here we talk about no value. We talk about a value x, right? What will be the price of car, what will be the gold rate tomorrow, right? Predictors. So we will be doing predictions here in supervised. Ultimately, again, to summarize the supervised learning, we if the data set, see, again, input to the machine learning is a data. If the data set clearly contains the features and the labels, if that kind of data you are feeding in learning, that kind of data you are feeding to the machine, it those kind of we have to apply supervised algorithms. We have to apply supervised algorithms to find the output. Okay. So data is labeled like this. See, female, male, male, male. I'm giving some sample diagrams. This is like teaching your kid. When you're teaching your kid, this is apple, this is orange. If you see the first class UKG LKG books, you will see that there are some apple, orange. You're teaching, then there is an exercise. If you see, after that chapter, there is an exercise chapter where only that picture is given. You are asking your children, your child, to tell whether it is an apple or an orange. How he is able to tell, he or she is able to tell, learning it from the previous data. Same thing is your supervised learning. Okay. So we do feature extraction. That's what, if it is round in shape with something orange, if something, it is something with something bend like this, we call it as apple, right? So based on the features of that particular object, the kid is learning. Same with the machine is learning. So classification, again, this is what. So height and weight is given. You have to tell, based on height and weight, you are trying to tell the gender here, whether it is male or female, right? So based on height and weight, you are classifying whether that the given object is it male or female. This is about regression. In regression, we'll try to find out a value. See here, see, I'm classifying whether male or female. Whereas in regression, I'm finding out the value x. I'm trying to find out the value x. So this is about some supervised learning algorithms. What we have: linear regression, logistic regression, and KNN algorithm, support vector machine, decision trees, neural networks. All these are supervised learning algorithms. The next category is unsupervised. In unsupervised, whatever data I am feeding to the machine, that data does not have any stickers. In supermarket, we are having stickers now on foods. The stickers are not there. Okay, so that kind of data set which you are feeding to the machine is unsupervised. So when you have to apply unsupervised for some problem where you will not do predictions, when there is no sticker, how will you know? You will not know. If I ask you, I every day I send you to supermarket, there are some apples without any stickers. So, but every day the number is changing. You go to the billing counter, he will say 50 rupees. The other day 45 rupees. The other day 55 rupees, 35 rupees. It is changing every day. How is it changing, that you don't know? There is no sticker on that. So only thing what you can do here, either you can tell, you can separate, these are the costliest apples, these are little cheaper apples. That kind of learning you can do. But what is the cost, you cannot tell. You can only separate them. You can say, I see, after 20 days of visiting the supermarket purchasing apples, 21st day when you take an apple, you can make a guess whether this apple is no will it be costly or will be cheap? You can separate that, only can be done. So in unsupervised learning, whatever data you are feeding to the machine, it does not have any label. It is like the system trying to learn without a teacher. It is simply like this, no label at all. So see here, the input in the previous algorithm, if you see, along with the input I was giving here, I was giving the input and also the annotations to get the prediction. But whereas in the unsupervised, we don't give the annotations, we don't give the sticker, we don't give the labeling, we only give the fruits, only give the input. The ML model will try to separate them. We can only separate them. That's what the application of this is, clustering. The unsupervised learning algorithm is all about clustering. See, clustering model, dimension reduction model, we have two parts here, right? So some important unsupervised learning algorithms are clustering, anomaly detection, dimensionality reduction, association rule learning. So the most important is clustering. Why? Since there is no stickering, there is no labeling on the products, I can only separate them. Similar ones I can group. Oranges can be separated, apples can be separated. That's it I can do here. And the third one, reinforcement learning. This is a different type of learning compared to both supervised and unsupervised. Here we will see this example. See, when you are playing game, when you are playing any game, right? You know, if you make a mistake, I think you are aware of this or not. Snake and ladder, snake and ladder, this game you might have played sometime in your life. No, you roll a die, if you get a number, you go forward, right? If you get a ladder, you go up, and if you get a snake, you come down, right? Same kind, reinforcement learning is little similar to that. What is happening here? You are trying to no take one action, you are trying to roll one die, whatever you are getting, based on that, if you are getting a nice number, you might get a reward with which you can climb. If you are getting a wrong number, you might snake might eat you and you fall down. So in reinforcement learning, what we do, we try to learn from actions. We start the game, we take one step forward. After taking that step forward, you realize that it is wrong, then you will come back and again go back to the next direction. If it is okay, you if you get a reward, whenever you take a right step, you get a reward. Whenever you take a wrong step, you get some punishment. So accordingly you will be doing that, right? So see here, in this example here, there is a fire, then fire is the environment agent, might be some firefighter, and there is water, right? So observe, select action policy. If you go, where you have to go when you see the fire, you have to first go for the water bucket, then come here. But if you go here, you get that heat, so you keep running towards here, right? So you get punishment here in reinforcement learning, right? So the learning system called an agent in this context can observe the environment, select and perform actions, and get rewards in return, or penalties, negative rewards. And you learn that way. And it must learn by itself what is the best strategy called policy, some rules of that playing that game. Okay, so reinforcement is that type of a thing. We don't talk about any algorithm here, we give the environmental, we tell the environment setup, we give that context, we ask it to play the game, and when it is playing the game, it will automatically learn by taking the actions. If it's a nice action, it will get reward. If it's a wrong action, it might no get penalty. Okay, so that is about the different types of ML algorithms: supervised, unsupervised, and reinforcement learning. Now, there are a lot of algorithms. Okay, there are a lot of algorithms. How are these algorithms? I meant to say, mm, uh, like I explained you about generative AI, deep learning, neural networks. What is machine learning? What level can they help? In the same way, there are a lot of ML algorithms. What are these algorithms? In simple terms, let's try to see this. These things you have to explain to students if you're a teacher, and these things also will help you to remember. If you're a new learner of machine learning, this will help you to know remember the ML algorithms. These examples you can relate to yourselves also. Okay, so I hope you have no queries in the different types of ML algorithms. If so, we will proceed further. Any queries in till now in the types of ML algorithms? Okay. Yes. If no queries, we will proceed to the next concept, that is machine learning algorithms in simple terms. Okay. Simple terms means I'm going to talk about some simple examples. Regression. When you talk about linear regression, what is this linear regression algorithm? What kind of problem it can help? Right? See, you can have lot of examples. You can take some examples. I have put some simple toy examples here. What are these examples? Right? So linear regression, imagine you are saving money every month to buy a bike. You want to purchase a bike, for that you are saving money. So the question here is, linear regression can help me in how many months do I have to save to purchase a bike. So for those kind of problems we go for linear regression. Okay, so for how many months do you have to save? So if that is the context, if that is the context, we have to apply linear regression algorithm. Now the next one is logistic regression. Okay, when I have to apply this regression technique, that is logistic regression. Imagine you are deciding if it will rain or not based on the clouds. You are seeing on the in the sky there are clouds. Will it rain or not? You want to decide it. For those kind of things, wherever you want to predict yes or no outcome, you have to go for logistic regression. Right? So linear regression to find out how many months I have to save the money. That X. Here it is yes or no problem. Then you go for logistic regression. Decision trees. Okay, what is this decision tree algorithm? These are all algorithms. We are going to talk them if time permits, but I will just this will help you in understanding how are they different from each other. See, both are regressions, but linear regression is finding out that X. Logistic regression, it will tell me the answer as yes or no. Decision trees, you want to make a decision, like choosing what to wear based on the weather. See the weather outside, is it hot? Then what should I wear? If it is little foggy, what should I wear? If it is raining, what should I wear? This kind of decision you want to make, then the decision tree techniques. Right? So a decision tree helps computer make choices by asking series of yes and no questions. Support vector machine, this is again one important algorithm, ML algorithm we have. What is this support vector machine? See, there is a basket full of apples and oranges. You want to separate them. You want to insert one paper, one card in between them, such that they are separated to each other. Right? So how do I separate, how do I place that particular card? But the apples and oranges are mixed to each other. Okay, so think of separating apples and oranges in a basket by drawing the straightest line possible. This SVM helps us to find out that perfect line, which I can separate them. I can cluster them into two separate things. Then random forest. The best one which I am no which I always use in my general life as well. Right? I think this is one important algorithm in machine learning which everyone should follow in life, kind of life suggestion also for all of us. What is this? See, I want to make a decision. Suppose my friend wants to join, maybe he has got three offers, maybe one in TCS, other in Infosys, other in Wipro, something in Capgemini. Like this, we have four offers. Now, which one should he choose? Somebody tells TCS is like government, you join this. Somebody tells Infosys, no, again, I'm not against this, but 70 hours work week, they're talking, no. Somebody will say no for this. So everybody will have their own opinions about these companies. Best thing what you can do, or what the candidate can do, ask all his friends. F1, he tells this. F2 tells Infosys. F3 tells Wipro. F4 tells TCS. Like this. F5 gives TCS. F6 gives Capgemini. Like this, you ask 10 friends. After asking 10 friends, which company most of them voted, that is your final answer. So random forest is kind of that. Instead of taking a decision by yourself, you take advice from many friends and combine their answers. So random forest is combination of multiple decision trees and you find out the popular answer. Naive Bayes. Okay, again, this is based on the Bayes theorem in probability. What we try to do here, see, if you guess the flavor of the candy by its color, you are making a prediction based on what you already know. If I give a orange, yellow color chocolate to you, if I ask you what is its flavor, you can guess either it could be mango or pineapple. Little, if there are little lowish in color. If I give something in pink in color, you will guess it could be strawberry chocolate. How are you doing that? Based on what you know already. So naive Bayes is a classifier. It will classify that based on the past information, based on the past knowledge, what you already know, right? So that is about the naive Bayes algorithm in machine learning. Then K means clustering. What is this? Again, there are again clustering means grouping together similar items. You are having lot of toys in a basket, big basket. If I ask you to separate them, if I ask you separate based on the metal, you can separate it, plastic separate, metal separate, or some glass item separate. If I ask you separate based on the color, you can separate them. So that basket full of toys are there. Depending on our criteria, you can separate them. So clustering is all about grouping, trying to sort the data based on the some similarities. What is K nearest neighbor, right? So it is again K nearest neighbor. This is solving some other kind of problem. What we try to do here, see, I want to find out, I want to read a book. I'm traveling somewhere for 15 days, I want to read some novel while traveling. I want to buy a good book. Which book to buy? I will ask my friend. I'll ask my friend. So it's like finding your favorite book by asking friends for recommendation. KNN finds the closest neighbor to make predictions. So you will ask 5 friends, whoever's way of thinking and their way of thinking is matching, you will take whoever is close to you. That decision you will be taking. So for those, we go for KNN. Then we have PCA, principal component analysis. Very, very powerful algorithm in machine learning. What is this? You are traveling somewhere, you have a suitcase with you, and you have all your clothes, your items with you. All that stuff you have to fit them into this suitcase. PCA algorithm help us in arranging the clothes. Okay, such that all this information is neatly arranged and fit in suitcase. Gradient boosting, again, imagine a better video game. So when you are playing video game, you make some mistake, next time you will fail, second time you will improve, third time you will improve more, fourth time you will improve more, much better. So gradient boosting is through learning, trial and error. You improve it, you improve it again, you improve it, and you become by rectifying your past mistakes, you will become in that particular game. So gradient boosting, such kind of algorithm, when my machine is learning, I am giving the data. My machine is learning from the data, but it is making some mistake. So I will apply gradient boosting technique while learning from the data, such that it learns and rectifies the mistake. Again, it learns and rectifies the mistake. Ultimately, it gives me the perfect output. Neural networks we have seen. Again, neural networks, CNN, RNN are all similar types of neural networks. Here, we human brain type of working is done here. In CNN, we talk about. You remember your school friend long back? You did your SSC, your 10th class. You have studied long back. You see somebody in train or some bus stand. You think, no, I have seen this fellow somewhere. How you are placing it, you don't know his name, but you only know that photo or that face of that particular candidate or the person, right? So new convolution neural networks, generally your brain is learning based from the pictures. In such case, we have to go for neural network. If you are learning from the text, then you have to go for recurrent neural networks. So if the data set is images, go for CNN. If the data set is text, some story, you go for recurrent neural networks. Autoencoders. Okay. What is this autoencoders? Again, understand this one very important algorithm again, and it falls under deep learning technique. But let's see. You have a piece of paper with you, a big piece of paper, and it is raining, and you want to carry this piece of, when it is raining, if you hold it as it is full paper in your hand, definitely it will get water will fall on that and the paper will be damaged. So what you can do, you can fold that paper into multiple folds, put it in your pocket so that it is not getting wet, it is in safe. After that, you can take it out again and see the paper. It is same as that. When you have paper, when you are folding it multiple times, the data is not lost, data is intact. So autoencoder plays a major role where you have a very big picture with you. You try to convert that picture into small, tiny picture. You play with that small, tiny picture. You do some analysis. You expand it back to the original size. Autoencoders reduce the data size and then reconstruct it. So when the image is very big, it will reduce that into small size, and after that, it will try to reconstruct back to the original one. For those kind of problems, we go for autoencoders. Bayesian networks, genetic algorithms, reinforcement learning. So these are again different types of ML algorithms we have. So again, I'll quickly summarize what we have seen here. I'm just trying to you or tell you those ML algorithms in simple terms. What is the difference between regression? These two, linear regression and logistic regression, what is the difference? In linear regression, tell me how many months I have to save the money to purchase the bike. Logistic regression, it will tell me whether it will rain or not. Yes or no type of question, right? So this way you have to remember and teach to students. This is one example what I have plotted here, but you need to put lot of examples, so that way they can learn and understand about the ML algorithms. So though as I mentioned, we have very few ML algorithms, what we say, in the machine learning we have supervised, these are the algorithms, and in unsupervised these are the algorithms what we generally play with. Okay, so this is what in simple terms to understand the I think you understood these algorithms in simple terms. Now let's move to the some fundamentals of machine learning. When you are building ML model, we should know what are the fundamentals, right, with about the ML models. Let's see types of data. Okay. Data I have to feed, machine will learn, try to understand the data by using some uh, that is the ML algorithm which I have to write. Okay, so you have to adopt ML algorithm based on the problem. But before we go to that model, before we go to the machine, we have different types of data. What are different types of data? One is labeled data, includes a target variable for prediction. Unlabeled data, we have seen these two, labeled and unlabeled. Third one is numerical data, means represented by numbers, age, income, salary, years, all these things are numerical. Categorical data like male, female, apple, orange, spam, not a spam, those kind of. And ordinal data like categorical data, ordered category, clothing size L, we know this, right? We when you go for S, M, XL, double XL, like this we have the categories. So difference between categorical and ordinal data is, in categorical we have less types, only male, female, pass or fail, 0 or 1, like this. Whereas in ordinal data we have multiple categories like this. Okay, so these are the different types of data which we have to handle. So depending on the type of data, your ML model, you have to design all those pre-processing you have to do. The next one, data splitting. Okay, data set you got, maybe you are working on software defects, you want to predict the software defects for a program, you got some data set with you, right? So you have to split that data into three parts. One is training data, validation data, and testing data. What is this training data? This training data contains input and output pairs. You will give this data to the machine to learn. After the machine is learned and it gave me a model, after it is learning and giving me a model, ML model, right? I will validate it. So used to optimize the model hyperparameters during training. During training, this validation data will help us to know whether it is nicely building this model or not. Then testing. What I will do? Okay, test training and testing, training and validation is completed. In the testing part, we don't give the output. We give only the input and ask the output. Okay, if you see here, when you have this data, training model learns from the task, learn the task, validation, which model is the best one to validate for which kind of model this data is working fine, that you will see. Then how good is this model truly? After building that model, how good it is? That information we get it here. One important point I would like to highlight: earlier it was 70% training and 30% testing. Later people told 80% training, 20% testing. Again it became 80% training, 10% testing, 10% validation. Like this, there are a lot of things. After some latest what we say, inventions or no discoveries in AI, like generative AI, large language models. For training, it is said to be 95%, and it is 2.5%, 2.5% for testing and validation. For training, almost 95% of data you have to give. Why you have to give this much of data? Because the what we say, based on the data, if the data size is better, if the data is of higher size, if you're training with more data, the ML model will nicely build the model. The ML model will be nicely no working for us. It will give us the output. So you have to train it with more data. Next one, data pre-processing. These are all different steps. This is just kind of glossary of different items what is linked with machine learning. So data pre-processing, we do cleaning and normalizing, and we do feature selection and engineering. What is cleaning and normalizing? Lot of times the dataset contains a lot of junk values, missing values. So those we have to clean and fix those values. That is cleaning and normalizing. And what is feature selection? In that data set, it can have a lot of features. If I talk, I have feature F1, F2, F3, so on, F100. If you have 100 features, do you need all these features for your ML model? One example could be, you want to know these are the subjects studied by the student: F1, F2, F3, F100. Some student S1, he has got job in software company. He has got job in software. This student S1. So my task is to identify which subjects played an important role for him to get this software job. Suppose there is a base course, mechanical foundations of mechanical engineering. Will we already know that this course cannot directly help the student to get a software job? Maybe some programming course, P1, P2, some database course, D1, D2, those courses might help the student to get job, but not the mechanical engineering subject. Okay, so that also we have to do. We have to select the important features. Selecting relevant features or creating new ones to improve model performance. So these steps also we do. Now let's go for the ML algorithms. I think you are no understanding the flow. Let's see the first kind of algorithm, that is supervised learning algorithms. As I have said, there are two important steps here. I don't say two algorithms, I say two types of problems. So the first kind of problem is predicting a value. Second kind of problem is predicting yes or no. Predicting yes or no, 0, 1, those kind of things. So based on that, we have two important algorithms: regression and classification. Let me take you to algorithms. Keeping the time limit in mind, I'll be just giving an overview of some of these algorithms in short duration. So in regression, what is the important goal here? See, it is a supervised learning task. The goal is to predict a continuous numerical output. Continuous numerical output, that it could be stock price, house price, temperature, and etc. What is the output here? Output of regression model is a continuous value. Maybe it will tell the prediction house price in New Delhi could be dollar 10000, dollar 10,000 in Delhi next year. So that cannot be give. So for doing this regression task, what all algorithms do we have? I can do linear regression, I can apply polynomial regression, decision trees, support vector machines, and neural network architectures. I can go for that. Now, okay, after building the models, what metrics do we use? What evaluation metrics do we use? So we use mean squared error, we use mean absolute error, root mean squared error, R square error. What are these? These are metrics. See, you choose one problem, you choose the data set, data from that problem to the machine give you some output. Is that output 100% true or not? That you can, so whatever ML model that machine has given to you, is that accurate? How, what is its performance? Is it doing better or not? Is it giving correct output to me or not? That I can evaluate using these metrics. So very popularly used metrics, this MSC, MAE, MSC and R square, lot of metrics are there in regression task. Okay, so again, loss function is one. Once you in regression, we actually have this. What you give, you take the data, you gave it to the computer, you gave it to the machine. I will, since I will, we are talking about machine learning, I will say it as machine. You give this to the machine will give you some output. Okay, once this output is given, you are using some evaluation metrics. Based on that, you identified that this output which you have generated is 80% better. It is only 80% doing well. It is not 100% accurate output what you got. Then what you can do, you can do some optimization here. We can do some optimization which can improve. Again, I will accuracy. Then this is what the final model. So you do a small step called optimization. For that, we talk about loss function, we optimize that. Okay, so this is about regression. Linear regression, there are different types. If you are again, one important variable, that is dependent and independent variable. Okay, so you are trying to find out a response between the dependent variable and the independent variable, right? So if you are dealing with only one such independent variable, it is called simple linear regression. If you are dealing with multiple, you call it as multiple linear regression. It is like, I have no, I want to find out, the power generated given the wind speed. Only based on wind speed, I'm having a turbine, I'm having a turbine. Okay, based on wind speed, I tell today morning 10 a.m. the wind speed is some around some 100, some value like this 100. Then I'm asking you, what is the power generated by that turbine? Okay, wind mills kind of thing. Then this is one simple linear regression. But if I say along with the wind speed, the temperature, current temperature also plays a role. To identify the power generated along with the wind speed plus temperature, both are playing the role. Then these kind of problems, we use multiple linear regression techniques to identify what is the power generated given the wind speed or less. Okay, so we have two types, simple linear regression and multiple linear regression. This is as same as you are constructing no line, drawing a line y equal to mx plus c, slope and intercept form, what you have studied in mathematics in your schooling. So that is about the linear regression. And again, for house price prediction, for lot of applications we use this. We try to fit one best line, fitting a best line we say here. With that data, you try to find out which one is the best fit. So this is all about that. This is what gradient I was talking about. You have to optimize that, we use the gradient part here. I'm just skipping this quickly. Then we have multiple regression. Previously, only based on number of bedrooms, we used to tell the price. Based on size, we used to tell the price. But in multiple linear regression, we see about size, number of bedrooms, number of floors, age of house. All these factors play a role. So these kind of problems are multivariate linear regression or multiple linear regression. So this all comes into that. Logistic regression also same. We try to do a classification, we use probability concepts here to know, identify whether the data belongs to class 1 or class 2, 0 or 1, male female. For those kind of things, we go for logistic regression. And I'll just quickly skip this. Decision trees, you want to decide whether no, given a insect like this, there are two types of insects. What type of insect is this? Is it type 1 or is it type 2? That I want to identify. So decision tree, we have already seen that it helps us by asking a series of yes or no questions. It will help us in knowing no, whether this insect belongs to category 1 or category 2. So there's lot of yes or no. See here, abdomen length 7.1. Is it yes? Then type 1. No, again go like this. So based on yes or no questions, the decision tree helps us in identifying the outputs. So then we have about classification. Regression is that then we talk about classification. We try to classify the data based on the categories. So we have binary classification, dividing that into two types, like whether a person has a disease or not. Multi-class classification, multiple classes. You're telling which species of this flower belongs to which kind of species. Okay, so we have linear classifiers like logistic SVM, and we have non-linear like KNN and decision trees. So these four fall under classification algorithms, right? And what metrics do we use to evaluate them? We use accuracy, confusion matrix, precision recall, F1 score, ROC curve, cross validation. So all these metrics are used for evaluating classification algorithms. Once you have that algorithm, once you give that model data to the ML machine, it will learn and it will classify the data. Whether the classification, what the machine is doing, is it proper or not, these metrics will help us in knowing it. Okay, so dimensionality reduction, as I said, this is one more algorithm what we have in machine learning. When you have a large data like this, it will identify only those few important columns from the data set to get output like this. So we try to delete some information, and we try to, we again, one important algorithm is PCA in dimensionality reduction. You have a lot of data points like this. We try to project them in a single dimension. We are trying to reduce the dimensionality from 2D to single dimension. Same thing, it is used. What are the current challenges? Okay, I tried to cover some basics of regression and classification algorithms, keeping in mind the duration of this session. I limited my discussion to certain concepts, but the next session onwards, we are going to talk about deep learning. What are the challenges in machine learning? Why are we moving towards deep learning? Because one thing is insufficient quantity of training data, then non-representative of training data, you are unable to represent the data properly, poor data quality, right, and irrelevant features. So when you have these things, ML algorithm can go wrong if you're choosing bad algorithm, or if you have bad data. Okay, so we can solve some problems using machine learning algorithms, also using deep learning algorithms. But when you have to go for deep learning, when the data set is very high, when there are complex features to understand, we go for deep learning algorithms. When the data set is small and simple and it is very easily understandable, we go for machine learning, right? So Microsoft released this one. They have used some algorithms. See, when the millions of words, when it was 1 million, the accuracy was around 75, 80, 85. But when the data increased to 100 million or 1000 million, you see accuracy is almost reaching to 99. So as the data increases, the accuracy increases. But when the data set is increasing, when I have large data, I cannot apply machine learning, I have to go for deep learning. Okay, and I would conclude my session by talking about one important slide, that is, we need more AI builders. Why? See, you all have joined this FDP. We see this much big group of people talking about AI, and we know some set of people using AI today, but we have a very very small set of people who are actually building AI. Okay, so I conclude my session by saying that we need lot of AI builders. Please focus on building AI models, writing ML, building ML models, ML or deep learning models, and converting them to products. Productionization is very important, because that's one very area I would recommend. If somebody is pursuing research or somebody wants to pursue research, you focus more on ML ops. Okay, means People are writing, doing data science steps. They are doing a lot of pre-processing, and lot of people are writing research papers by building ML models, proposing new ML and deep learning models, but they are not converting that to products. So productionization of ML or AI models has more scope. That's what machine learning operations, we call it as ML ops. So this one area you can focus on much. And I said we need people, who are actually building AIs. There is huge demand. It is a buzzword. Everybody is talking ML, AI, but people are not trying to build and solve the problems. So maybe this should be a starting point for all of us to build more AI models and convert them to products, so that they are available for solving problems, or making our life easy. We know AI is trying to make our jobs easy in some part. So and one more insight I would like to add. Recent, there is in one of the articles which I was reading, AI cannot take away jobs of teaching. If you are a teacher, you should feel safe. AI cannot take. It can take, but not fully. So there could be some call center jobs which AI is taking away, but teaching is one job which AI cannot replace. It cannot take away. So we are safe at least in that point. This is what I have learned recently from by reading one article. Okay, so that's it from my side. I am open for questions. Students, let me know. Participants, let me know if you have any queries in what I have discussed.
Any queries from participant side?
Any queries? Let me know. PPT will be shared. I'll share the PPT. I see. Yes.
Good evening, sir.
Yes.
So you talked about linear regression where we used to solve yes or no problem. Similarly, decision tree algorithm, we use yes or no problem. Can you please tell me on which situations you go for logistic regression and on which situations you go for decision making,
Right.
decision tree algorithm?
True. See, when the output is by, when my problem is only one question, yes or no, I go for logistic. But when in decision trees, when you have to make lot of decisions, okay, plus two is completed now. After plus two, I have to go for, I can go for engineering, I can go for degree, I can go for some diploma, I can apply for some army jobs. I have a lot of options. Again, if I choose this engineering, which branch to choose? So when there is a sequence, a lot of questions are there in that, then you go for decision tree. So it involves a lot of complex questions at each level. But if it's at a very simplest level, we go for logistic regression.
Thank you, sir.
Yeah.
Any other questions, sir, from participant side?
Hello.
Yes, please.
Yes.
Yeah, getting good quality of data set is very challenging in our research work. So, sir, can you
Yes.
please suggest uh,
About data set.
how to?
See, yeah, we have publicly available data sets, I understand, but all those data again not, they're not high quality data. So lot of data engineering has to be done, which can actually convert that data to a readily, or I would say the best data, which can, we can build models on that. So when you are not finding a proper data set, then we have to generate data, but one step we can do. And otherwise, a lot of data engineering, data pre-processing need to be done to have quality data.
Okay. Thank you. Thank you, sir.
Fine, then if no questions,